Hello. Today we're gonna derive the kinematic equations using algebra and graphs. So to start off, we have a velocity time graph here with initial velocity here and final velocity here. And we just make time equal to 0 to make it easier. And then this right here would just be TF or final time. Um, so for our first equation, we solve for acceleration, which is just acceleration is final velocity minus initial all over final time minus, since we made time initial 0, we can just say minus 0. And everywhere I put this little theta symbol, that's just a 0. Um, and then using this, we isolate our final velocity, which would just be AT is equal to VF minus V naught. And then solving for VF, we get VF is equal to V naught plus ATF. So this ends up being our first kinematic equation. Alright, so with that given, we can also find our second kinematic equation very easily. Um, and to do that, we again go back to our graph here. Let me just try to have a second copy of this graph. Oh, it keeps pasting it there. Okay, so we have our graph here again, and then to our second equation, we're trying to find our position. So to find position, we just have to take the integral of the velocity. So the integral is just the area under the curve. So to find this area under the curve, we just split this. Sorry, it should be more over here. We just find the area by splitting our shapes here into this triangle and this rectangle. And when we do that, we see that this height over here for this triangle is going to be VF minus V naught. And then this right here is going to be just V naught. And then this base over here is going to be T final, time final. So when we use the formula, 1/2 base times height, so that would just be 1/2 TF times. Also, we discovered that VF minus V naught is equal to AT over here. So we can just make the height AT. And then this is our triangle right here. And then for the rectangle, we just do V naught times TF. So when we add these two up, we get 1/2 AT squared when I multiply the 1/2s out. And that's added to this right here, which is just V naught plus, or sorry, V naught TF. And then, by the way, this was solving for position. So this is our second kinematic equation. All right, so I'm just going to erase this part over here. Um, Actually, I can make it bigger, maybe. I guess I can't. I'm just going to erase this first thing over here. Alright, so now that we have our second equation, we basically just, um, we're given that VF is equal to V naught plus AT from the first equation. So using this information, let's solve for time here. So when we solve for time, we get VF minus V naught over A, which is equal to time. And then now that we have this t value in terms of VF, V naught, and A, we can plug that into our second equation, which we got over here, 1F AT squared plus V naught times TF. So when we do that, we get delta X is equal to V naught VF minus V naught all over A plus 1 half A and then VF minus V naught all over A squared. To eliminate this A, we can multiply everything by A on both sides, so that would just give us V naught, and I'm also distributing the V naught here, so that would give me this, plus 1 half VF minus V naught, and then VF minus V naught here. And then to eliminate this 1 half here, we multiply every single thing by 2. So that would give us 2a delta x is equal to 2 v naught vf minus 2 v naught squared, plus that becomes a 1, so we ignore it. Yeah, and then this would just be, and then we FOIL this out, so that would just be vf squared minus 2v naught vf plus v naught squared. Alright, so we've gotten this far. I am going to erase this top part over here to get more room. So now that we have this right here, we can actually just eliminate or combine all the like terms. So I see that we have this positive 2v naught vf and then this negative here. So we can eliminate those. And then this just turns into 2a delta x. And this becomes this and this when you add it, it becomes, first we have our vf squared. So I'll just write that. And then this just becomes negative v naught squared. So this is what our equation narrows down to. And with this, we just solve for vf squared, or we isolate that. So when we do that, we get 2a delta x plus v naught squared. So this right here ends up being our third kinematic equation. And that's about it. Thank you.